Hey everybody. So we're going to, in this module, I'm going to give you some instructional videos and some practice on the things that we did not get to finish about Unit 9. We had barely started Unit 9 before school ended on March 13th. And so I know some of you are really anxious to find out what information was in the units that we didn't get to cover. So my plan is to offer the rest of Unit 9 and Unit 10 and Unit 11. I'm going to make some instructional videos and give you some practice pages and answer sheets that you can work through independently. And you can just email me if you have any questions or if there's something that you don't understand. None of this is able to be graded because of the lack of equity. We don't know for sure that everybody has internet access, and we don't know for sure that everybody is able to be able to do the material, so it wouldn't be fair to grade students who are not able to access it. So none of this can be graded. This is for your benefit to have a jump on next year. Your geometry teacher is going to cover this material. And you may very well forget it over the summer, but if you've seen it once, then the chances of it coming back to you quickly are a lot better. So we're going to talk about scientific notation. You know what scientific notation is. Oh, by the way, the paper that I have here, the notes paper, you can download and print if possible, or you can just follow along with me with a blank piece of paper and you can copy the problems and do it on blank paper. You don't have to have this document. And the answer key is also available in this module for you to download and check your work. Okay, so what is scientific notation? So scientific notation, I'm going to make this a little bit bigger so when I write on it, it doesn't look quite so sloppy, is a compact way of writing very large or very small numbers. And it is most typically used by scientists and mathematicians. I think that was supposed to be an E. Okay. So you guys have probably had some practice changing numbers to scientific notation. Let's remind ourselves for a real quick second what scientific notation looks like. I'm going to write in this section down here. You have the first part, which has got normally a decimal, and then you have times 10 to some power. There are rules for what this beginning part needs to look like. It has to be a number between 1 and 10. So it has to be larger than 1. Actually, no, it can be 1. But it has to be less than 10. So it can't be 10. It has to be 9 point something. So between 1 and 10. So we have to be careful that we are paying attention to that because, for example, if somebody wrote let's see, if somebody wrote 14.6 times 10 to the third power, that's not appropriate scientific notation because this part is larger than 10. So you have to pay attention to that. So you may remember having to translate numbers into scientific notation. So in order, looking at this number, 284,000, I would want my decimal to be between the 2 and the 8 in order to make a number between 1 and 10, 2.84. That means I need to take my decimal, which would be back in the back, and I'm going to erase this. It would be here at the end. Remember, a whole number has a decimal at the back because it's 0.0. To get the decimal up to the 2, I need to back up 1, 2, 3, 4, 5 spaces. So 2.84, don't ever drop any of the digits. You don't have to put the zeros, but if there are non-zero digits, you have to include them. 2.84 times 10 to the, and then is it positive 5 or negative 5? Well, there's a little trick that I'm going to show you. If we come down here, I'll go ahead and write it in. We're going to use something called LARS, which means left add, right subtract. So if I come here, I moved my decimal to the left. So if I start with nothing, that means I'm going to add 5 spaces. 0 plus 5 is 5. So this is a positive 5. Okay. Let's look at the second one. The 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of a day 0.000000268 seconds shorter. So we're going to write this in scientific notation. Where would I place the decimal in order for it to be a number between 1 and 10? I would place it right here between the 2 and the 6. So in this case, I'm going to start where the decimal is currently located, which is right there, and I would have to move it 1, 2, 3, 4, 5, 6 spaces. 2.68 times 10 to the, and if you remember Lars, left add, right subtract. Since we went to the right, we are subtracting, so it would be -6. Okay. So you can use that, you can use those rules and give these a try, 1 through 12. And then we're going to come down to how to add or subtract, multiply, and divide scientific notation. Okay. So for adding and subtracting, you have to make sure that the exponents are the same. So for example, looking at number 13, you have 10 squared and 10 squared. These are okay to add. But if you look at, for example, number 14, you have 10 to the 7th, 10 to the 6th. Not okay. So if you have common exponents already, this is easy, easy, easy. All you do is add your bases. So 3.4 plus 5.2 is 8.6. And then you keep your exponent. How hard was that, right? Easy, easy. Of course, it's going to get more complicated. Take a look at number 14. I'm going to zoom way into number 14, so I have lots of space here to write. I have an exponent of 7 and I have an exponent of 6. And let me put this way down smaller. Okay, so I need for both of those exponents to be the same, which means I either have to change the first one to a 6 or change the second one to a 7. It does not matter which one you decide to change, but in the end, you're going to have to make sure that your final answer is in proper scientific notation. So sometimes you can tell by looking at it. If I were to change 9.5 times 10 to the 7th to a 10 to the 6th decimal, I would have to subtract 1, right? Left add, right subtract. That means I would have to move this to the right, and I would have 95 times 10 to the 6th. Well, I already know if I take 95 and add 1, I'm going to get 96 something, and I'm going to have to change my scientific notation at the end because that's not proper notation. So what if I changed it the other way? What if I kept the 7 and I changed this one? If I changed this to 10 to the 7th, that would be adding, right? Left add, right subtract, left add. That means I would move this 1 to the left, left add, so 0.11. So now if I take 9.5 and add 0.11, I get 9.61. And this is already in proper form. And I can keep this one. So, you can change it at the beginning. You may also have to change it at the end. I'll show you how we would have gotten the same answer. Let's say that we did change this one down to a 6 instead, and we had 95 plus 1.1. So 95 plus 1.1 is 96.1. And then I would have had to back this up to make 9.61. Going to the left means add, so that means bump that up to a 7. And you see I get the same answer. So you can do it either way. Whichever way makes you happy, doesn't matter to me, but you just have to have common exponents before you can add or subtract. All right, let's try number 15. How about if you guys pause the video for a second and try it and then come back to me. All right, so now you're back. So I have a -4 and I have a -5, and I think I'm going to change the -4 to -5 just because I feel like it. So in order to make a -4 into a -5, I'm actually subtracting 1, right? Think about your number line. In order to get from -4 to -5, you are going down 1. You're subtracting 1. So left add, right subtract. If I'm going to subtract, I have to move this to the right one space. So this is going to be 72.4. If you did it the other way, that's okay. Hold tight. We'll see your answer at the end. Now I can add these. 72.4 plus 3.18. This is 75.58 times 10 to the negative fifth. Now 75.58 is not correct scientific notation. I need to move this to the left one. 7.558 times 10 to the left means add. So I need to add 1 to this, which would take me back to the negative 4. And there's my answer. Okay. I want to show you one more. I want to show you number 19 on the next page. Oops. Let me bump this back down. Let's look at one that's subtraction. So if you look in the middle here, you see a subtraction sign instead of addition. So that just means we're going to take the two bases and subtract them. No big deal. 8.17 minus 2.6 is 5.57. Times 10 to the fourth. You keep your base. All right, that's the only difference. The only difference is what you do with the base. You either add the two bases or subtract the two bases, okay? So why don't you should take the video, you should pause, and you should go ahead and do these problems, 16 through 24, and pull up the answer key and check yourself and see how you did. I'm going to go ahead on to multiplying and dividing. Multiplying and dividing, I think, is actually a lot easier because it uses two rules that you already know, which are the product rule and the quotient rule. Remember that if you multiply two exponents, you add them, and if you divide exponents, you subtract them. We're going to use that rule. And then at the end of the problem, if you have to, you're going to use LARS, which is left add, right subtract, in order to put your answer in correct scientific notation. So for number 25, for example, we're going to multiply, look in the middle here, multiply 2.8 times 1.9. If we multiply those two together, we get 5.32. And then since we're multiplying, we add our exponents, and 7 plus 4 is 11. That's it. Okay? Multiply the base, add the exponents because we're multiplying. Let's do number 26. Here's multiplication. I have 1.3 times 4.7. 1.3 times 4.7 is 6.11. And then I have 10 to the ninth times 10 to the negative fifth. So we're going to do 9 plus negative 5, which is the same as 9 minus 5, which is 4. This becomes an exponent of 4. Be careful with the negatives. I'm going to scroll you down here to number 29 because we have division. Now for division, remember, instead of adding the exponents, you subtract them. So we're going to take our bases and we're going to divide because we're doing division. So 3.72 divided by 1.2 gives you 3.1. And now we have 10 to the 8th minus 10 to the 5th gives us 10 to the 3rd. And there's our answer. Let's look at number 31 right below that one. We have some negatives here we need to be careful. So the fraction bar shows us that we're dividing. So 1.2 divided by 5 is 0.24. And then negative 5 minus negative 6 is really negative 5 plus 6, which equals 1. So this is 10 to the first. Now, if we look at our base, this is not correct scientific notation. It has to be a number greater than 1. That means this decimal needs to go one place to the right. So it has to become 2.4. Well, if you go to the left, you add, right, subtract. So we're going to subtract 1 from 1, and we're going to have an answer of 0. 2.4 times 10 to the 0. And that, boys and girls, is how you multiply, add, subtract, multiply, and divide exponents. All right. Go ahead, like I said, finish off this page of worksheets up to here, number 32. Before you keep going, pull up the answer key and check. And then when you feel like you've got it, you can go to the next page, which is more problems converting to scientific notation, and then doing the add, subtract, multiply, and divide at the end. All right. You can check the answers for this one too. If you have any questions about any of this, all you have to do is email me and I'll be happy to help you out. Bye.